Right, so this is video 2, and here's the issue. On the previous 2, they all look the same. This one looks all like a parabola. Parabola, parabola, all happy parabola. In the end, it was a parabola. Here, all of these looked cubic. Cubic, 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 cubic. Yes, you have the plus c. You can figure out the plus c if you plug in a specific point. Here, though, they don't look the same. There's 3 options. I have one that goes whoop and zips up. That's the black. The green zips down like the black, but it's negative version of it. And then the red just stays red. So there's a difference here because there's kind of a variety of shapes or paths that can be chosen. And the big reason why is there's a y involved now. Okay, it is dy dx equals y instead of a dy dx equals x. Okay, this I'm going to cover tomorrow in the video lecture. It's okay that you don't know exactly what it is now. I will cover this one specifically tomorrow and how to handle the black and the green and the red and which path do I want to be. This one has x's and y's in it. Okay, and we can also see some different slopes to it. Now, one thing to notice is this. I really want you to see flat, 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 flat. Why? Because who's 0 there? X is 0, and 0 over anything equals 0. So all of those are flats. They're all zeros. Now, notice though, nothing's going on this grid part here. Why? Because y is 0. And if y is 0 there, we're in trouble because anything divided by 0 is undefined. Blows up in your face. Blows up. So notice I didn't put any blue tick marks there yet because I don't know what to do with it. We've always said all through life that the fraction where 0 is in the bottom is undefined. Your calculator says it. It blows up in your face. You're going, what do? I don't know. How do I do this? Well, let's try one. Okay, let's try one like at 1, 0. At 1, 0, your dy dx would equal 1 over 0, and we've already said that's undefined. But what happens if I tried like at 1, 0.001? Is that pretty much the same spot? It's just a little bit higher. So let's see what happens. Your dy dx would be 1 divided by 0.001, which is a lot. Is it 1,000? Let's see. 1 divided by 0.1 is 10. Then 100. Yep, it's 1,000. So at 1, 0.0001, so like right there, just above it, just barely, my slope is super duper positive, like ridiculously positive, like infinity positive. Because I want you to think this now. Yes, we've always said 1 divided by 0 is undefined. But if we're talking in slope world, what does 1 divided by 0 mean? It means up 1 over 0. If we're talking slope world, up 1 over 0. So that means basically up 1 over 0, 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 up 1 over 0. All of those seem to be vertical lines. Now, I'm going to erase something here in a second. All of these over here, it would be a number divided by 0 gets you positive. Up 1 over 0. All of these, though, would be kind of like down 1 over 0. But is it still being shown by a vertical line? You're basically going up and down at that moment. Now, the one I need to erase is, let me get rid of all these kind of unknowns. Delete. Let me get rid of this so we don't get overwhelmed with that. get rid of this. We don't get overwhelmed with that. Here's the issue though. The one guy that you cannot say anything about is right there at the origin, because it's kind of a debate. I totally get that it could be the red version, because 0 divided by anything is 0. But I also totally get how it could be the, let me make these all black because we've been talking about them. I could also see how it could be the vertical version, because anything divided by 0 is a vertical slope. So is it red or is it black? Is it red or is it black? Well, 0 divided by 0, it's kind of the red version. It's kind of the black version. So it's too much. It's an overload. Don't do anything. Just leave it blank. Okay. Now, in this shape, here's what your possible routes could be if you're a railroad and you're a train trying to go through the railroad tracks. If I'm here, maybe I do something like that. Now, I want you to realize I want that to be a little bit above something. If I'm down just a little bit below that dot, I might look something like that. I could have over here a path that looks something like that. Do not restart on me. I could do a yellow version that would be something like that. But it's very interesting to note here, everywhere the slope is 1, everywhere the slope is 1, everywhere the slope, uh-oh, I don't know what happens there. Everywhere here the slope is 1, everywhere here the slope is 1. And likewise, I'll do it with this, I don't know, bright green, no, orange. Everywhere here is slope -1, everywhere here is slope -1, everywhere here is slope -1. I don't know about there, but everywhere here is slope -1. So look at all of these options that I could be. I could be on a green happy parabola sort of looking thing. I could be on the yellow sad parabola. I could be on the black or the purple like sideways parabolas. Or I could get stuck driving straight diagonally through the orange or the pink. It all depends on which city I need to go through. If I need to go through a city up here, it looks like I'd be following that happy green parabola. Now, you don't know how to get those paths yet because of the issue again that this slope field has a y in it. Summarizing those first 4 on this first page, you knew how to do this because you're used to x. You knew how to do this because you're used to x squared. The last 2, though, have a y in it and have a y in it. And it seems like there's a lot more going on with that y in it. That's what I'm going to talk about tomorrow. Okay? For today and the rest of the day, we are going to focus on just making sure we can set up slope fields. Meaning, can we set up the blue ticks? Okay? Turn the page, and you're going to see 10 different slope fields and 10 different slope fields already given to you. They're already tick marked out for you. So those are basically the blue little ticks that I've made on the front page. And our goal is we're going to try and set up which number, which equation goes to which graph. Okay. Now, there are 6 different kind of keys to figuring out which one goes to who. I think it's very important to look for places where the slopes are 0. Okay, there are going to be many places where slope is 0 or where the little ticks are flat. Focus on those. I would focus on those first. You can look at the x-axis and the y-axis and see if you see a trend there. Also, you'll notice sometimes the slopes only depend on the x. Sometimes the slopes only depend on a y. And we've already seen that on the front page. Because here's one all about x's, and we've mentioned if it's all about x's, then every vertical line has the same ticks. Every vertical line has the same ticks because that's where the x is changing. on one with y's in it, only y's, then every horizontal line has the exact same slope to it, because that's where the y's are constant. Man, I think I just screwed something up on that last one. Here, why is it vertically nothing changes? Because who changes vertically? The y coordinate. Does the x change at all? No. Since the x doesn't change at all, and my guy is only in terms of x's, then they are the same throughout that vertical line. Here, on a horizontal line, who changes? The x's change, but the y's stay the same. And since my function is only in terms of y, everywhere on that horizontal line is the same. Sorry if I mumbled that. I apologize. So, look for places where the slope is 0. Look for places where vertically things don't change, or horizontally things don't change. That would mean here on number 4, if it only depends on x, then vertical the same. If it only depends on y, then horizontal the same. Okay. You also might see a trend where maybe one region is all positive slopes, then in another region is all negative slopes. Well, that's pretty easy to locate based off plugging in x and y's, not their values, but their signs. So it's going to take you a while to get used to this idea. So of the 10, I'm going to do one of them on my, with you guys next. We'll take a look at that, and then I'm going to let you guys dive into the other 9. Okay, so let's look at one of them together first. So I pulled up A. Okay, so we have slope field A. My goal is to try and help us find which slope field equation it fits. And of those 6 ideas that I told you, the first one is probably honestly the biggest, most important one to do. And that is, where is the slope 0? Well, here, let's see if we can find where the slope seems to be 0. So I'm going to highlight it in blue, and let's focus on it. It seems like I have these flat little sections here where it's 0, and that trend keeps going down. Everywhere there, the slope seems to be flat. Okay? So with that, that is going to be so important for us to realize. Everywhere there, the dy dx is flat, which is 0. Now, that seems to be a guy. That seems to be a specific path being followed here, or a specific trend line. That seems to be linear, and it seems like all of those flat ticks occur on this line, y equals x. So this seems to occur when y equals x. Anywhere where y equals x, it seems like it lands on a flat blue tick mark. So if that's the case, if y equals x, could I rearrange it and say maybe y minus x equals 0? Or could I say x minus y equals 0? Do you see how I just subtracted over either the y or the x? So I'm looking at a y minus x or an x minus y. And if you're going, uh-oh, which one is it? Well, one way to narrow it down is number 5 is the only one that says dy dx equals x minus y. So that's my prediction for it. If you want to get a little bit more feel for it, you could also kind of notice that everywhere here in this zone, all of the slopes are positive. And everywhere in this zone, all of the slopes are negative. Why would that be? Why would it be everything below the line y equals x seems to have a positive slope, and everything above the line y equals x seems to have a negative slope? In the green world, who's bigger always? Like, give me a point. Any point that you want in this green world. Let's say 3, 0, or 3, 1, or 3, 2. Who's bigger? X is bigger. And if x is bigger, when I do x minus y, x is the bigger number, y is the smaller number, so x minus y equals a positive. And over here, any point that you take here, like 0, 2, 0, 1 is a point there. Way over here, you could do negative 2, 1. Every point that you do, y is bigger. And if y is bigger, then when I do x minus y, and y is the bigger number, that's going to land on a negative. So that's kind of my way of figuring out that graph A goes with number 5. Okay, so I want you guys to hit pause, and I want you guys to try and figure out on your own what the other 9 go to. And once you're ready, you can hit resume, and you will watch me analyze it on my own. This is how my head works when I do this. Now, I'm going to do a couple more on this video, and then the third video will continue with this trend. Okay? Hit and pause. All right, so snippet. This one is 7, which is dy dx equals x plus y. Here's why. I focus on the exact same problem of the idea of flat, 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 flat. That all occurs in this path of y equals negative x. So if y equals negative x, I can add over and I get x plus y equals 0, which is good because everywhere there, my blues are 0. So that's my way of analyzing that one. And you can look at more details if you want. Okay. Let's look at this one. Okay. Now, one thing to notice, again, focus on where is it 0. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. And it seems to be zeroing out here. So it is 0 when y equals 0 or when y equals 1. The next thing I want you to realize is everywhere horizontally do the ticks change? No. So if the ticks don't change horizontally, then it's only in terms of y. So the one that makes sense to me is dy dx equals y minus 1. Now, only in terms of y, check. And then realize this, if you want to verify where those slopes are 0, they are 0 when y equals 0 or when y equals 1. Okay, so that dy dx is y and y minus 1. That is option 1. Okay, let's look at another one. Okay, here. So I'm trying to zone in on where it's flat. I'm also trying to see where it seems to be very vertical-like and go from there. I'm seeing flatness, I think, here. Flatness. And I also see verticalness, like super steep, there. Now, on the green, who is always 0? X is always 0 on green. And on red, Y is always 0 on red. I don't know if this is officially right yet, but I'm going to take a stab at saying Y over X. So anywhere on the Y-axis, Y is 0, and 0 divided by anything is 0. Anything on the X-axis is where X is 0, so that would make that undefined. I'm kind of liking this. You tell me what you think, and we'll look at this on the next video.